Okay, so in R, let's say I want to go through and assess normality. So I've put in a set of data points here. So remember in R, to enter in data, we pick some name for our distribution. So I'm going to call it X, okay? And then I'm going to write out the list of all the numbers that I'm interested in, separated by commas. And don't forget this C here to sort of concatenate all those numbers together. And then we're going to assign it using this arrow. So that's less than, and then a dash to the value of X. And you can see over here that we've got the value of X over here in our environment. To get a histogram, you're going to use the code HIST. So HIST, and then you're going to do that argument to our object X. So if I run HIST, then what you'll notice is that a histogram will pop up over here in your plots window. And so, I don't know, in this case, it doesn't look too normal. But the other thing about histograms is histograms are really affected by bin width. So in here, the bins are, one unit apart. And so if I change the bin width, that might change how the histograms look. So again, this QQ plot might be another alternative way to assess normality. So it's QQ norm. So if you run QQ norm on X, it's going to spit out something that looks like this. So again, this is our probability plot. It puts our quantiles, so for our data set, against some sort of theoretical quantiles if it was a normal distribution. And again, what we're hoping for here is a perfectly normal line if it's an exactly normal plot. So, it's a bit of a judgment call. I can definitely see those lines aren't in a perfect line here, but I'm not seeing any major patterning where it looks curved upwards or curved downwards. I don't see any tails that are sort of trickling off. So in my personal opinion, this is seeming okay for me in terms of assuming that it follows a normal distribution. So again, that's the code in R that you're going to need to assess normality. So HIST and QQ norm.